All right. I am going to prove the law of sines using these two triangles that I've drawn here. ABC and again ABC. They're congruent triangles. If I took one, I could rotate it around, get to the other one. They're oriented different ways. So the top one I've oriented so that BC is the base, whereas my second triangle I have AC as my base. And I'm going to use our definition of sine from back when we were doing triangle trig to prove the law of sines here. So let's remember that the sine of some angle, we'll call it theta, was always opposite over hypotenuse. So here I've drawn the altitude of this triangle, labeled it D, so its length is going to be D. Remember that an altitude always forms right angles with the base of the triangle that it connects to. So we have two triangles here, two right triangles. So we can use this definition of sine to come up with a proportion. So for our angle B, we're going to say that sine of big B is going to be the opposite to that angle, D in this case, divided by the hypotenuse, C. Similarly, for angle C, my sine is going to be D, which is still the opposite, even for this angle C. D is the opposite, except this time the hypotenuse is going to be B. Now, if we take both of these equations that we found and solve them for D, that's going to be our next step. So I'm going to have D equals C sine of B, and also D equals B sine of C. Now, by the transitive property of equality, I'm going to set these two values equal to each other because they're both equal to D. And thus, we're going to get that C sine of B is equal to B sine of C. Now, if I move my sines to the opposite sides, so I'm getting my C's together and my B's together, it will turn out that I have B over sine of big B equals C over sine of big C. So I'm pretty much halfway there. I got the B's and the C's all together. It's looking like I got 2/3 of my law of cosines. Now I just have to incorporate side A and the sine of angle A into the case. That's where my second triangle comes into play. And here I got to remember one thing. Got to remember that the sines of supplement angles are equal to each other. Okay. So here, my angle CAB, my angle BAE are supplement angles because they form a linear pair. We're going back to geometry on this one. So that means that sine of my original angle A, okay, what would have been up here, which is the single arc there, is going to be the same as the sine of this angle BAE. Okay. So with that in mind, I can now set up two more equations. Okay. My sine of A, so if this angle is the same as the sine of this angle here with the two arcs, that's going to be equal to E, which is my altitude of my second triangle, over C, which turns out to be the hypotenuse of that smaller right triangle. Similarly, if I take angle C over here, my sine's going to be E over A. Just like up top, here I'm going to solve both equations. So I have E equals C sine of A, which is also going to be equal to A sine of C equals E. Okay? And then at this point, I'm going to do just like I did up here, separate out my A's and A's and C's, and I'll get A over sine of big A is going to be equal to C over sine of big C. And now since I have this C over sine of C, and up here in this equation, C over sine of C, again, I'm going to use the transitive property of equality, and I can just say that A over sine of big A is all part of this big proportion. And that right there is my law of sines.